pineal gland, the thymus. Don't forget the thymus, because the thymus is going to come back to us when we get into the immune system. So just remember that the hormone that is released, okay, it's going to act on cells made in the blood. They're going to create the T cells. So if you know anything about T cells and their effects in the immune system, this is the gland that those cells have to go to mature. So one of the things that we left off was at the thyroid gland, and I tried to draw the picture of the follicle, and we left off at the point where we were talking about those parafollicular cells. In the thyroid, we've got follicle, 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 follicle. Cells that are in between are the parafollicular cells. And we were talking about the fact that they are important dealing with blood calcium levels. One of the things that our body is going to work very hard to do is to maintain correct calcium levels, mainly because of its effects upon muscle and nerve. So our bones, I'm not sure if you guys remember, okay, but from part 1, the structure of a bone cell or bones, okay, they are the perfect place for storage. We tend to think a lot of times, because people might hear something such as dry as a bone, okay, not sure if y'all have ever heard that term or not. The last thing bone is dry, okay, because it has a very good blood supply, all right, and because of that blood supply that exists, it's bringing in these components that can be stored, all right, and it creates what we know as bone, all right. Did your A&P1 professor talk about this bone cell? Okay, so to get these pieces laid down, they're made out of calcium phosphate. Does everybody remember that from part 1? That's called the hydroxyapatite, okay? Calcium, important for muscle and nerves. Phosphate is important in helping cells with those phospholipids, for example, okay? So those cells in the thyroid, if blood calcium levels are too high, their hormone that they secrete, which is the calcitonin, it will make those osteoblasts, okay? And remember, blasts are the immature form of a cell, and the way that the bone cells work, because osteomine and bone, they're kind of moving and secreting their product, which is the hydroxyapatite. So they get more active, secrete more bone, and build the bone. So if there's an increase of calcium in the blood, it deposits it in the bone, because the bone is the storage for calcium in the body. If we need it, the body breaks bone down, because the thyroid gland, and it showed it in the video, this gland on the posterior side contains 4 little nodules. Well, I wouldn't say nodules because they're glands. 4 glands, all right? They tend to be tiny. Before, we knew a whole lot about the thyroid gland. And did you see how in the video for the thyroid gland, if it was producing too much of the thyroid hormone, they talked about that digestible radioactive medicine, okay? And it went and it killed the thyroid gland, okay? Well, it used to be that if there were issues with thyroid gland, people would have it removed. And early on, when that took place, because we didn't know what these parathyroids did, okay, they got removed most of the time also. And then the person died. And it's sort of like, whoa, okay, this is not a good outcome of the surgery, okay. I don't think I would like that outcome, but hey, I don't know. So the parathyroids are very important. They secrete their hormone, which of course is parathyroid hormone, and this one, not under the control of the pituitary gland. But it works when blood calcium levels are low. The exact opposite of what the thyroid gland did. So now, if my calcium levels are low, and when I say that the body is going to regulate calcium levels very tightly, it does, okay? The smallest drop, it's going to affect it. The smallest amount too much, it's going to affect it. So if there's just a small drop of calcium in the blood levels, parathyroid hormone is secreted, all right? And what it wants to do, stimulate reabsorption. What does that mean? There's a definite difference between absorb and reabsorption. It's a second time. So if I took in the calcium that might have gotten stored by way of what happens with my parafollicular cells, that was absorbing. Well, now, if the body is saying, I don't have enough calcium, it can now go and get the bone to break down. Do you remember what cell that was for the bone cells?
Osteoclast.
Osteoclasts. All right? Because if you hear that term, clast, okay, that's breaking down. So it would break down bone, and what do you think that's now going to release into the bloodstream?
Calcium and phosphate.
My calcium and my phosphate. We don't need the phosphate. That can leave by way of the kidneys. But the calcium can be balanced now. So now, does this sort of explain why bone is dynamic? Hopefully in part 1, when you covered the osseous tissue. All right, you learned about a blast, which is a cell that works to build. The site is a mature cell, and that is for maintenance. Clasts are for breaking down whatever needs to get broken down. So the parathyroid hormone will work to get the calcium released from the bone and keep us from losing it in urine, which we'll get to in the kidneys. So the parathyroid hormone, before we knew about this and thyroids were removed and the parathyroids kind of went with it, okay, and the reason people died, okay, is because we couldn't balance calcium in the blood, which would affect their muscle and their nervous system, and there was nothing that could be done. Nothing. So they've kind of been like, oh, whoa, we're not going to try that anymore. Let's see about some other options. One of the biggest options they have now, they have medications that will work for both of these, actually, work for both the thyroid and the parathyroid hormone, and whether it's hyper or hypo. So that's a good thing. Then if people can't really get control of it, they can just simply take that radioactive pill, and it targets, supposedly, only the thyroid tissue and kills it. The adrenal glands. We've got one on top of each kidney. A lot of people tend to think they're one and the same, but they're not, okay? They do depend on each other, okay? The kidney depends on the adrenal gland depends on the kidney, okay? But this is our adrenal gland. When you're looking at this gland, which we had a cutaway view, but we don't, when you're looking at this gland, where it looks like a triangle, that middle portion is the medulla, the outer portion is the cortex. If you remember, do you remember how we had in the sympathetic division a nerve fiber that ran all the way to the medulla of the kidney? And in that area were these little modified cells, and it synapsed directly on the cells of the medulla, and our product that we tend to relate of adrenaline, okay, gets released. Does everybody remember that? So, this gland works as both an endocrine and then part of that sympathetic nervous system. The chemicals that get released, epinephrine. Have y'all heard of that one? In relationship to what?
Brain.
Hmm?
The study of the brain.
Because of the chemicals.
Adrenaline rush.
Adrenaline rush is what we tend to think about the most. This particular chemical, the epinephrine, I didn't want to get too detailed about it, okay?